Hello everyone. Uh, am I audible? Aniket, am I audible?
Yes,
Okay, fine. Okay, I guess everyone is there. Yeah. So, okay. Please ensure na, that you are in mute. Okay, because in the last class, some voice was coming. Okay, so other student get disturbed. Okay. Okay. So starting with the thing. Yeah. So what we did in the last class, basically, majorly we have seen what was the difference between your traditional algorithm, your traditional one versus your machine learning. Why the machine learning came into the existence, though the programming language was there. Okay, we have seen that thing. We have seen the pros. We have seen the cons. Um, Others, can you please mute yourself? Yeah, the voice is coming, I guess, from your end. So we have seen the basically the traditional machine learning, traditional method versus your machine learning. Okay. After that, this was something very important. The types of the machine learning. So basically, the types of the machine learning is nothing but it is basically how much supervision that you are giving to the particular model. Okay. On behalf of that, we have basically divided the type of machine learning into the four part, and we have seen the first one is your supervised machine learning, in which you were giving the input and output both the thing. That means your data was also there and your input was also there, and it was basically making some pattern, you can say, or making some kind of program. Okay, in the unsupervised learning, you was not giving any kind of input, you were just giving the output. Okay, and on behalf of that, sorry, you was only giving the input, you were not giving any kind of output. On behalf of that, it was basically making a kind of pattern, or you can say the program. Okay, and after that we have seen the semi supervised. So I told you the example of Google Photos. So semi supervised is basically the combination of your unsupervised along with your supervised machine learning. So what happened, just like I give you the example of Google Photos, this one. Okay. So suppose what happened in the Google Photos, for the first time it asks for the particular face. Please define the identity of this particular person. Okay. So you have to define this thing only one time. Okay, after that, suppose one more photo come and if this face was similar to this face, so it will basically put this face to this, you can say, the cluster, or it will basically put in this category. Okay, so semi supervised machine learning is something partially supervised. Okay, you can say partially supervised, or you can say it is partially unsupervised in nature. Fine. After that, we have seen the reinforcement learning. Okay, and reinforcement learning is very very important in today's world. I have given you the example of chat gpt, how the chat gpt is using the reinforcement learning in training its own model. Okay, in refining its model. So what the reinforcement learning do? Basically, there is one agent, or you can say the child. Okay, and it is basically based upon the two factors, and that factors is your penalty and the reward. If it is doing the good thing, so it will definitely get some reward. Fine. And if it is not doing the good thing, or it is getting harm, so what it will get? It will get some kind of penalty. Slowly, slowly, just like a small child, this agent will also learn the thing slowly, slowly, and these learning will be based upon your penalty and the reward. Fine. So this was the reinforcement learning, the fourth one. Okay, and we have seen, I told you one more example, this game, the Go game, that was developed by the Deep Mind. It is basically a lab in Google. Okay, a kind of branch, you can say the sub branch of the Google, where the core researcher works, okay, on these topics. So they have developed one game, Go, that was totally based upon the reinforcement learning. Fine. Okay. After that, I told you how the chat gpt is basically using. Okay, so in this I given you the thing that, suppose there is one question. Okay, and for this question the chat gpt is giving the wrong output. What happened, they will basically store your data. Okay, for the same question, one output. For the same question, another output. But this answer is correct, this is wrong. Okay, so this thing will be learned by the chat GPT. This thing will be observed, and this is something, a kind of penalty, you can say. Okay, and this is something, the kind of reward. So suppose another student came and they asked the same question. So this time it will only give this kind of answer. Okay, not this one. It will not give you the wrong answer. So in this way, ChatGPT and the other large language model, they are basically solving the problem of hallucination. Hallucination is a problem in the machine learning. Sorry, in the ChatGPT or the large language model, whether they are not giving the correct answer. Okay, so we will discuss that thing when we will learn the generative AI. Okay, and this is the thing I will tell you these things later on also, how they are using in depth. Fine. So starting with that thing, so we have divided the machine learning into the four parts. Okay, again we can divide the machine learning into the two parts. The one is your online, and the second is your offline. Offline, you can say, or you can say the batch learning. Okay, and this is called the online learning. Fine. So, what is learning? First, we will understand what is learning. Okay, learning is nothing but training your model. okay, so that it can predict some result. Okay, it can predict or it can classify some given input. Okay, some input. So in machine learning, we are basically having two types of learning. Okay, the first one is your batch learning or offline learning. The second one is your online learning. So we will first understand what is the difference between the batch and the offline learning, and what is the difference between the offline learning. Okay, the online and the offline learning. So what happened? Just like coming to this topic, we will first understand this scenario. Okay, so what happened? Suppose you are hosting some website. So what you do? You basically host this website in some production server. Okay, and that server is having some kind of IP address. Again, this IP address you get some kind of URL. Suppose www dot suppose agsync.in. Okay, this is the kind of URL suppose. And what this URL doing? This URL is basically hitting this kind of IP address. Okay, suppose you are a client. So what you are doing? You are directly hitting this public IP. Through this, you are hitting this public IP. Okay, public IP. So this is a kind of production server. The same thing happened for the machine learning model also. Machine learning model also are deployed in a kind of production server. Okay, they are basically deployed in a kind of production server where a user or a client, what they do, they basically hit a kind of IP address. Okay, when they hit a kind of IP address, so they basically get their result. They get their result. That result could be a classification, or that result could be a regression, anything. Okay. So in the just like your machine or just like your website works, in the same way your machine learning models are also works. Okay. But the difference is only that it is your machine learning model and this is your website. That's it. Okay. Now the thing is that why we are basically reading these things, why we are learning these things, how in production these things work. The example is that the reason behind this thing is that what happened. Uh, I tell you. Uh, okay. Yeah. So what happened? Basically, you can do two types of learning. Two types of learning. Okay. One learning is that in which you can make the whole model. You can make the whole model at a time. Okay, you can make the whole model and push that model into your production server. You are pushing your machine learning model in your production server. Okay, so this kind of learning is known as your batch learning. Okay, there are two types of learning. The second one is your suppose you are not pushing whole model at a time. You are putting just a small amount of model in your production server. Okay, what mean small amount of a model? That's mean you are training that model on a small data. For this you are training the whole model, or you can using, or you can say you are using the whole data set at a time. Okay, for this kind of learning, and this kind of learning is known as your batch learning. So batch learning in the machine learning is the approach, okay, where your model is trained on the entire data set. You are not dividing, or you are not basically dividing, you can say, the data into small chunks. So instead of that, you are using the entire data at once. Okay, once the model get trained, what you do, you basically push that model into your production server. So this kind of you can say the learning is known as machine learning. Sorry, batch learning. Okay. So what you do, you basically uh, produce the large chunk. Okay, and that large chunk is known as your batches. So rather than incrementally small inside, what you do, you basically you are using the whole model, right? So the batch learning is same as your offline learning. Okay, offline learning, you can say the another term for the batch learning. So what happened? Why we are calling it offline learning? why we are not calling it just only the batch learning. What happened? This kind of training the model on the entire data set is done offline. It is not done on the running server, you can say. Okay, this is something important. That's why it is called the offline learning. Fine. So it refers to the training the model on the historical data in an environment separate from the production or the operational environment. This is important. Okay. That's why this kind of learning is known as your offline learning. Fine. And training the large amount of data into your local server, into your machine itself. Suppose I will basically train my model in my laptop, okay, without running my model in my production server. Okay. After that, once I train my model completely in my machine, I'm pushing that model to my production server. Fine. So that kind of learning is known as your batch learning, or you can say your offline learning. Fine. So you can say once your model is trained, so you can test and deploy on your server. Okay. The problem associated with this type of learning is that the model is static. Once you train the model on the particular data set, you can't change the model. Okay, you can't change something. Suppose right now you are having X amount of data, and you have trained the machine learning model, and you push that particular model. Okay, suppose new data comes, that data is y, but what you need to do, you can't basically change this model y, because right now you are following your batch learning or your offline learning. Okay, so this makes this type of learning static in nature. Fine. And it does not deal with the real time system. Okay, so this is the major drawback, that you can't use this in the recommendation system. Okay, you can't use in the spam detection system. So these are your drawback. So what happened in the recommendation system? Suppose right now we are watching some soccer game. Okay, we are basically watching some football game. After some time, what we watch, we are watching some cricket game. So it should change our recommendation based upon our own data set. Okay, that we are watching. So that kind of recommendation is not possible in your batch learning, or we can say in your offline learning. Fine. Any doubt till you? Anyone?
Abhinay, first, I have trained one model, and
Yeah.
now I have another set of data, which is quite good. So
Okay.
instead of I cannot train on the same model. I have to add old data plus new data, and I have to train new model again. That is what something batch learning, right?
Uh, no, no, no. Can you just repeat the last one? You mean to say you have suppose X data,
Uh,
okay? You have trained upon and you made one machine learning model, fine. After that, you get one more kind of data, that is your Y data,
right, correct.
right? And you want to again train this on your machine learning model, right?
No. So I
Okay,
have
so
to combine X and Y, and I have to entirely train new model.
yeah, exactly, exactly, exactly. So this is the kind of you can say the batch learning. Okay, the same thing I told you here. So if
What
you are
is
using the
some case, in some case, is it benefited? Or I mean, how much time it take to train?
or see, in case of time, you can say it will take a lot of time because you will do entire thing from the scratch only.
So we already have codes and everything. I mean, only the data we have to train, right?
But data training will also take time. So that's the important thing. No?
So
Code
how?
is it depends from the data to data. It depends from the data to data. How much data you have. Suppose in the X amount of data you are taking, suppose 4 minutes, let's suppose, okay, and you are having Y data. So what you will do, you will, and this will take 2 minutes. So combined, it will take 6 minutes to train the complete model.
Okay, so this kind of model might be traditional one. I mean, not much using people.
This is not used in kind of recommendation system. It is used once. So suppose you have just trained the model and you don't want to touch upon for a long period of time, for 1 year, for the 2 years, and so on and so on. Okay. Suppose you have servo ATM machine. So So ATM machine also consists of some kind of algorithm or some kind of code. Yes or no? Yeah. So these kinds of basically model are basically static, you can say, or these kinds of learning are batch learning or offline learning. Once they are trained. Okay, we don't need to basically include the more data set to make it more good, so on, so on, so on. So they have their own application, and another kind of learning, that online learning, that have their own application. So online learning is basically, I will come there. I will tell you how the online learning work.
I
Fine.
mean, this model doesn't follow the life cycle. I mean, upgrading and all those things.
No, 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 no. If you want to upgrade, you have to basically just pull out your model from your server. Okay. Again, you have to train from the scratch. After that, you can push into your production server. So that will take a lot of time and will consume much resources also as well. So this is some kind of drawback. That's why I told you it will be static in nature for a while, because you are not basically changing the things or changing the data set again and again for a certain period of time.
Got it.
Yes. Okay. See, what you can do basically, same thing. You can update the data, okay, in 24 hours or the 7 days and so on, so on, and again train the model and put into your server. The same thing that you was. Yes. And what kind of disadvantages, why the people not prefer this kind of learning? Okay, the lots of data, because when you are training the model, you need to again combine these two data sets. Suppose new data set come, so you again need to combine these three data set and train your model from your scratch. So training the model from the scratch will take a lot of time, even resources also. Suppose just like a chat gpt. Okay, suppose just like a chat gpt 3.5 was there. Fine. And what the OpenAI want the new kind of chat GPT, that will be your 4. So if suppose it consists of X amount of data, okay, and maybe from the different resources they get Y amount of data, a new kind of data. And again, they want to basically train the X plus Y value. So they will not train from the scratch. What they will use? They will use basically X amount of data over there, and they will use online kind of learning. So that will basically remove these kinds of disadvantages. The lots of data, you don't need to train the chat GPT model from scratch, because these are taking lots of resources, electricity, and many things are there. Okay, so this kinds of learning is not preferred. Okay, and hardware limitation is also there. Okay, and suppose you want to just train for a year, you want to just train one model for a year, in the second year, so at that moment you can use this kind of batch or offline learning. Right. So this is the scenario where you can use, where your data is not continuous, you don't want to continuous updates. Fine. So there you can use. Okay. Okay, so again we have the online learning. So maybe many of you are get to know what is online learning. So instead of training your model from scratch, what you do, you basically increment the data, what the new data you have basically taken from anywhere, or you get some from anywhere. So what you can do, you can basically just append that kind of data. Suppose initially it was X. So what we did, we basically appended Y amount of data. Okay, in your online server only, where your model is deployed. So what it will make, it will basically adapt your continuous changes to the data or your environment. The same thing happened in our recommendation system. So in recommendation system, there must be some in the machine learning. There must be some model, okay, and that model is basically learning from our own data set, right? So what happened when you log in for the first time, and you basically use Flipkart or the Mintra for the 2 days, okay, it learns something. After suppose after third and the fourth day, okay, it learns something new. So this kind of learning is known as your online learning. Fine. See, suppose some of the apps, or you can say when you are using some kind of Android or the Google TV, their performance increases as you increase the usability. And some of the apps also claim the same thing. Once you started the using some kind of apps, your performance, the performance of the particular app will certainly increase day by day, day by day, day by day. Why? Because they are doing the online learning. Okay, they are training the model based upon your data set. They are making that thing very very personalized in nature. Okay, so basically it is used for the YouTube feed also. Yes, feed changes in our YouTube. In the recommendation system, we can see the online learning. Okay. In the fraud detection recommendation, stock price prediction is a very, very good example where you can see the online learning. After that dynamic price model, the same thing which have been used in the stock price prediction. Fine. So this is something a kind of the online learning. And one more thing is that it is used in out of school learning. So what does it mean? Suppose in the batch learning, uh, suppose in the batch learning, you can train only X amount of data. You have some limitation. So what you can train only X amount of data, but right now you are having X plus Y amount of data at a present moment. Okay, so what you can do, you can basically divide this data set into the two parts. One will represent your X and the second will represent your Y. So at that scenario also, your online learning works. Okay, when the data is out of core, means you have very very large amount of data that at a moment you can't do the batch or the offline learning. Okay, so at that moment you can use the online learning, that you can train some data at a present moment upon the X. Suppose Y amount of data is left, so what you can do, you can basically train this data in the production server. Okay, so this is something, the difference between your online and offline learning. Online learning is also having its drawback. What kind of drawback we will see? Okay, so okay, so what are the disadvantages? Suppose the first disadvantages. Suppose you get in a real time the wrong data. Okay, this is something. Suppose the sources where you are getting the data and you are training your model on the online. Okay, and suppose there is some kind of mistakes, or you can say some values are missing from your data. Okay, but you are not basically seeing anything, you are not getting anything. So what you will do, some kind of wrong data will comes in your online server and that will make your model worse. So this is the very very risky, and this is the major major drawback of the online learning. Okay, and it is very tricky to use because in a running server, in an ongoing server, you are basically training your model. Fine. So that's why it is very very important that you should know how to use the online learning. Fine. So there is one thing here. Model monitoring system is basically implemented when we are using our online learning. Fine. That we are basically continuously monitoring our model, what kind of result it is giving, and what kind of basically feed, or what kind of you can say on what kind of data it is using to train the model in an online way. Fine. So these are the two disadvantages that we basically often see in the online learning. Fine. So these are some example cost effective faster solution you can get. Okay, it is a cost effective in nature because you have already trained on the X amount data. Now you need to train only Y amount of data. You don't need to train the model from the scratch. So that will be cost effective. Even it will give you the faster solution. Why? Because the training time will be less. Okay, and it will be the volatile scenario. Why it is called the volatile scenario? Because we are training the model in a given runtime. Okay, and that runtime is in your server. So this could be volatile in nature. Maybe some bad data come. Okay, maybe the data which was not related to your model, that may come. So that will result into some volatile kind of scenarios. Okay, so this is usually dependent upon the environment. Okay, so moreover you can say that your online learning is dependent upon your environment, how what kind of data you are getting and so on and so on. Fine. So after that, there's one more term, and this is your hyperparameter term, you can say. We will see later on when we will do the hyperparameter tuning and all those things. There is term learning rate. Okay. So what is learning rate? The learning rate is the rate at which your model get trained. Okay. So it does not forget the past data and keeping working on the new data. So this is something your learning rate. Suppose if we take example of some human, okay, human. Suppose I'm learning something, okay, and my learning capacity is very much. So maybe my learning capacity is very much. Maybe I forgot some kind of data, my previous data or my previous chapter, okay, or maybe my learning rate is very slow, okay, and I am not forgetting any kind of my previous chapter. So these things need to be basically we can say these things need to be taken in concern, or we can say these things need to be taken in scenario that we should basically keep our learning rate in such a way that the model should not forget the previous data while it is learning the new data. So mostly the learning rate is the numerical value. It is mostly taken as 0.01. Okay, we will see why it is taking 0.01. It is experimental value. It is experimental value. This is the experimental value. Learning rate is always taken as 0.01. Okay, and this is the experimental value derived from the different researchers or the scientists while they were performing the model training. Okay, so you can take different values. L is equal to maybe 0.001. L is equal to zero point 0.1. Okay, what happened in this case? The learning rate is very fast, so it forget its past data. In this case, the learning rate is very slow. Okay, so though it not forget its past data, but it cannot remember the new data also. So these were the two drawback, that why they have taken 0.01 as the you can say the ideal value for a learning rate, right? So this parameter is very important. We will see afterward with the help of the graph also. Okay, we will make one graph that will be hyperparabola, you can say. Okay, so this is the meter.
Vinay, which
Yeah.
parameters are more affecting for learning rate and forgetting rate?
For the learning rate, which kind of parameter you want to say
Parameters are
affecting it?
affecting, I mean, what kind of main parameters which is slowing down learning rate for one machine and increasing learning rate for another machine?
It basically depends upon the incoming of the data. What is the speed of the data that you are it is coming?
Speed of data or quality of data?
No, no, speed of the data, you can say. The quality of data is something that we will see in the feature extraction part. That one hot encoding and all those things.
Okay, I mean, but what factor depends on, I mean, speed, how can you, how we can understand that speed, this machine is learning with this speed, and what are the factors behind the speed?
Speed is something just like the rate at which you are giving the data to your model to learn. You can say you have learned about epochs. Epochs is a value that it is a kind of loop running to basically train the model on the same kind of data again and again and again. Okay, so once we run this kind of epochs, after that it is giving you learning rate. So we will see after this thing once we do the coding and all those things. So I will tell you there how you can basically define this learning rate. Okay, how you can basically define the your data speed also. That this data is coming slow or that data is coming fast. So how you can define the learning rate. Okay. Okay, we can differentiate the offline and the online learning, okay, based upon the complexity, based upon the computational power used in the production, application, and the tools. Okay, so your offline learning is less complex. That is very, very natural because you are basically training the model from the scratch. Okay, you are not pushing your data in a running time server. Okay, your online learning is complex because it involves from a very period of time. Okay, you are pushing your data in a real time. Fine. The computational, the fewer computational high single batch training it will need. Okay, it will need the continuous data ingestion. That means you are giving the continuous data to your model, which result in the consequent model refinement and the computation power. Fine. And used in the production, it is easier to implement because so you have to just train the model in your local system and you want to push to your server. Okay, it is difficult. Why it is difficult? Because you have to basically do the model monitoring also, so that it not get trained on the fake, or you can say the dummy data or the wrong data. Fine. So the application is just like the image classification. This is something very, very, you can say the good example. Suppose you want to classify between dog and cat. Okay, so you have taken the large amount of data. Suppose that data may be 20 million images of the dog and the 20 million images of the cat. So once you train the model upon these data set, so you don't need to basically train. Why? Because all kind of varieties of the dog, all kind of varieties of the cat must be there in 2 millions of images. Okay, so in that case your offline learning works very, very well. Fine. So in case of online learning, your application could be your recommendation system, okay, your economics, your health data, which is basically in which in this sector you are basically getting the new kind of data from a very certain period of time. It could be your 2 days, 3 days, 7 days, and 8 days. Okay, so at that moment you have to use your online learning. Fine. So these are some tools that we will discuss later. Okay, scikit-learn, TensorFlow, PyTorch are there, and in this we are using scikit-learn, Multiflow, StreamDMA, SMAO, MAO. Okay, so we will discuss these things apart from these conditions. Okay. Any doubt to anyone till here? Because next we will learn the instance-based and the model-based learning. So that is also kind of learning on behalf of your machine learning model is divided. Okay. Anyone?
Abhinay, I have one doubt.
Yeah.
Suppose you have developed a model for a hospital. Okay.
Okay.
And
Okay.
you have enough data set and the model is working fine. And if similar requirement is there for another hospital, so how
Mm-hmm.
easy or difficult it is to replicate or means transfer all the data, means how it works?
Okay. Okay. See, basically, your data is same, data set is same, or maybe a kind of data is same. Okay. You can say, suppose three columns are there in your previous data, three columns are there, all entities are same, right? We can assume this thing.
Yes, yes, yes. It's
Okay.
a
Okay.
similar same industry, so most of the things are same.
Will be same, exactly. Most of the things will be same. Okay, so what happened, suppose you have taken your data, okay, till your pre-processing thing, till your pre-processing of this data, all things will be same. Okay, definitely it will reduce your time in making the new model. Definitely it will reduce your time. Am I clear?
Yeah, you're
Hello.
clear.
Okay, okay, fine. Definitely, it will reduce the time. Okay, and maybe because see what happened in the machine learning now. Suppose you are giving 10 hours to train a particular model. So 8 hours are basically spent in the data pre-processing part, and the 2 hours are basically spent in model training. So though you are using same industry data, though you are using the same kind of data, so you can save your 8 hours. Maybe there will be one or two column changes, so that will take hardly 1 hour to refine that particular data. Okay, so 1 hour plus 2 hour, that will take 3 hours. Previously you were taking 10 hours to train the same kind of model, or you can say the same kind of industry model. So in this way, these things are very beneficial, right? Okay, now moving to next kind of learning. Okay, so behalf of the machine learning model, again it has been basically broken into the two parts. The first one is your instance-based learning. The second one is your model-based learning. Okay, so right now we will understand what is instance-based learning and what is model-based learning. Right? See, instance-based learning is nothing but, just suppose there is one student, okay, he learn the thing, he does not understand the thing, okay. So those machine learning model which are basically learning the things, which are just learning a kind of pattern present in the data, pattern in data. So that kind of model, basically they are using the instance based learning. They are only just memorizing the thing. Okay. On the other hand, there are some kind of machine learning model which are basically not learning the thing, they are basically understanding the pattern. They are basically understanding, just like the in school now we have the two kind of student. One who learn the thing, they don't understand what is the exactly meaning behind the scene, okay. And there are other kind of student who basically understand the thing in a very depth way, okay. So in this way, the machine learning also works in the two category. The one is your instance. That means it totally work on the memorization of the pattern. Okay, whereas your in generalization, that totally work on the understanding the pattern. Okay, and understanding one is known as your model-based learning. Fine. So some algorithms are there, just like KNN. KNN algorithm is there in machine learning. Okay, K nearest neighbor is there, which is basically work on this pattern, instance-based learning. Okay, it does not make any kind of model. It does not generalize the thing. It does not understand any kind of pattern. Fine. On the other hand, your logistic regression, your linear regression. Okay, these kind of model, what they do, they basically generalize the thing in nature. Fine. Once they understand the thing, so it's a very common thing. They are understanding the thing, so they will be more better as compared to your instance based learning. Okay, so this is the example, the instance based learning. Your instance based learning is also known as lazy learning, or you can say it basically follow your lazy approach. Why lazy approach? Because it does not give much focus on understanding the pattern. Okay, so instance based learning is the lazy learning approach where the algorithm memorizes the training data and uses it directly for the prediction. So instead of understanding the thing, okay, and example is your KNN, K nearest neighbor is the machine learning algorithm that is basically work on the instance based learning. Fine. Okay, so suppose we are having one table, and this table is basically representing your IQ. Suppose 77, 97, and this is your CGPA 9.7. Student is placed 1. Okay. After that, 87, 6.7. Student is not placed, and so on, so on, so on, so on. Okay. Your these X basically represent student is not placed, and y represent your student is placed, so represented by 1, represented by 0. Fine. So what we did, we have basically made one, this is your graph. Okay, in this graph we have shown all the students which are not placed and which are placed. Fine. Suppose these represent your x, these are in your orange, and these x are in your black. Okay. Sorry, this will be 1, and this will be your 0. Fine. And okay, fine. So what happened in this, suppose your new entry comes, this is your new entry. Okay, and its IQ is 7 points, its IQ is 103, and its CGPA is, you can say it is 7.5. Okay, now this model have to be basically placed this entry in such a way that it should come in this category or in this category. So it has to tell that whether this student is placed or it is not placed. Okay, so on which approach it works? It basically works on the approach of similarity. Okay, it will basically find the distance, it will find the distance, it will find the distance, it will find the distance from each point. In the same way, it will do for this also, this for this, and for this also. Okay, whichever the distance will be minimum for it, it will place this point in that category only. Suppose so it is coming in this category. Okay, and this category is representing the students are placed. That means this will give you the one result. Fine. So it is not making any kind of model. It is basically just memorizing the thing, and it is basically working on the approach of the similarity itself. Fine. So this is how your KNN algorithm works in machine learning, your instance-based learning, right? Okay. After that, we have model-based learning. Okay. The same thing. Suppose all these students are placed, so they have been represented by this thing. Okay. And these are not placed, so they will be represented on this side. Okay. So what the model-based learning do? Model-based learning basically make one kind of model. Okay. They don't rely on some kind of similarity thing or something. Okay. They make some kind of model. And what is in the machine learning model? Model are nothing but your function. Okay. So this thing, they will make one function, and this function will represent your curve. This is your curve. This is your curve. Okay, this is your curve that has been made. How? By understanding the pattern, not just by memorization of the pattern. Fine. So this will help you to basically categorize the new data or the upcoming data, whether it will be placed or whether it will be not placed. Fine. So the types of machine learning that comes under the model-based learning, these are your linear regression, logistic, and decision tree. Okay. So this concept is basically based upon the model-based learning. Okay. And these are some, you can say, some differentiation between your usual or the instance-based learning. Okay. Any doubt till here? Anyone? Anyone? Any doubt? You can write in chat also if you're having any kind of doubt. Okay. Suppose what we do, we basically erase these data. So can this model will, this kind of learning will work or not? Anyone who wants to answer this kind of question? Suppose we basically deleted. What was in this thing? It was basically utilizing these kind of data. They were utilizing these data set, your previous data set, to find the similarity, for the new data. So can we, does we need to use these kind of data after we have made this kind of curve? Anyone who wants to basically answer?
Vinay, can you repeat the question? I have not understood that.
Okay, so my question is, suppose in the instance-based learning, we were basically using your previous data. These are your previous data. Yes,
Okay.
we were using this previous data to find the similarity. So how we were finding the similarity? We were basically finding the distance from your new data to your previous data, right? And
Okay.
in whatever category it was coming closer, we were putting the new value in that category, and we were saying yes, it is placed or it is not placed. Okay. So my question is that, suppose in the model based learning, we have made one curve. We have made this curve, and this curve is your decision function, you can say, or your model curve, you can say. Okay. So does we need to write these data that does we need to write this data? Suppose your new data is coming, okay, and this data is having IQ, it could be 184, and your CGPA is 9.7. So does we need to basically do the same thing? Does we need to use these previous data set?
Okay.
So this is my
Okay.
question.
Okay.
Suppose I deleted these data sets. So it will work or not? It will categorize or not?
Ideally, it should not categorize. If
Why?
you delete the data,
Okay.
because model-based learning, what I understood, is based on something that it has learned, it has make that curve, and if a
Yeah,
new
it has
entry is
made that
coming, it will find out whether it belongs to, let us say, left side or right side, based
right
on
side.
some features or parameters, something like that.
Exactly,
But
exactly,
in
exactly.
previous case, we are finding the distance, the exact distance, where means new entry is closer to which particular entry. If entry
Exactly.
is not there, then it can, I means there is no point in finding the distance, right?
Exactly, exactly. So, what we can conclude? We can conclude that we don't need this kind of data in the model-based learning. That we can conclude because this curve is basically differentiating the new data, right or no?
Yeah, right.
So
Exactly.
Abhinav, I ideally like for this model-based learning, like so basically we are optimizing like whatever our model based on the data what we have, right? On
Yeah,
which we are training, right? And based on that, we are optimizing whatever the weights and coefficients and values should be according to it. So I guess so on the new data, we'll have to train the model, right? And then accordingly, it will do the prediction.
No, 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 no. We are not talking about the new data. We are talking about the past data only. Okay, this
Okay.
is your past data. Okay? This is your past data. On behalf of that, you have made this curve, and now this curve is able to basically differentiate your new entry, whether it will be placed or whether it will be not placed.
Okay.
Okay, so you don't need these data set. You don't need these data set to differentiate. Okay, for the incoming data.
Okay. So will it
Making
work or not? Like, even I'm confused. Like, if you can let.
sorry.
Yeah, but it will work or it will not.
No, it will work. It will definitely work if you will basically erase these data. It will definitely work because we have made this curve. Na? This curve will basically now be the, it will basically work as an indicator for the new data set. Suppose this is your new data set. Okay. If these values are basically lying in this area, so you will place above this curve. So whatever will come above this curve will be definitely placed. Okay, if it is coming in this region, that means it is not placed in nature, that student is not placed. Why? Because right now we are following this curve as a standard curve.
Okay. Yeah. Okay.
Okay, now get. Okay, so what we were basically doing in the instance based learning, we can't delete these data set because these data set was our main source in finding the distance from the new data to the old points. Okay, and based upon that we were basically finding the similarity. So suppose we do the sum of these, we are summing and getting the average, and this average is coming the 2, and average of these is coming 3. That means this data is closer to these cluster. That means it will come up with this cluster, so that means the student will get placed. Fine, so we can't erase these data set, but in a model based learning, once we basically made this curve, so we can delete this data set, our previous data set. Okay, they are of no use.
Got it. Yeah. Okay.
Okay, making that. So
Yes. Yes.
there are kind of machine learning models. Suppose KNN is there. So KNN is basically working on your instance based learning. Okay, but if we talk about the model based, so linear regression, logistic, decision tree, so they are basically using these kind of curve, and these are kind of curve are nothing but your model. Okay, your machine learning model. Fine. Your machine learning model in the PKL file or H5 file or something. That we will see after. Fine. So anyone doubt till here to anyone? So
Abhinay, how we can be sure that the curve which has made in the model driven,
yeah.
it's perfect, or
That is basically we can't sure it is basically you can say depends upon the data, okay, and depends upon the hyperparameter. What is your learning rate? How much epochs you are using? And after that, what you need to find? You need to basically find your accuracy, your F1 score, your precision, and so on. Okay. After that, once you get these values, these are your parameter which are very helpful in determining how much is the accuracy of your model. Just like in a over in cricket, we have the run rate. In the simple way, these are your parameter to define the accuracy, or you can say the precision of the particular model, right? So
okay,
suppose the accuracy is 80%, okay, upon this data set. So what you do, you change another algorithm. Right now you are using linear regression and it is giving 80% accuracy. So you can try with logistic regression. It is giving 85, that's good. You can use XGBoost,
okay,
okay,
but
it will
that curve
give.
will get changed when we change the algo, right?
Yeah, definitely it will change. Definitely it will change. Because this curve will only define now where the point will lie. It will up
Right.
or it will down. Okay. Suppose your point was lying over here. Now your curve has changed to this thing. Okay. Now your student will get placed. Before it was not placed.
Okay.
Making sense?
Yeah,
Yeah.
right.
Yeah.
But
So
out
these
of
things
so
will,
many algorithms are there, means is it like based on data we need to find out which algorithm is best suited for this kind of model, kind of linear
exactly. See,
regression? You just mentioned two, three. One was
yeah,
regression,
yeah.
another I don't
Got it.
remember, but
Okay. See, the thing is that not everyone, when I was doing my research also in IIT, so what we do basically, we basically do the data pre-processing. Till data pre-processing, everything goes very smoothly. Okay. But when it comes to implementing the algorithm, we need to basically try each and every algorithm, starting from the linear regression, logistic, decision tree, and so on, so on, so on. Okay, so suppose this is giving 60% accuracy, this is giving 70% accuracy. So we need to try all kind of algorithm. After that, we can assure that okay, this algorithm will work good in this type of data. Data as well as algorithm both are important in defining the accuracy of the particular machine learning model. Both are. Suppose maybe one kind of data is working good in linear regression, that may not work good in logistic regression. This thing happen.
can't we have such
Okay.
kind of model, new model, which will tell us कि we should use linear regression or other kind of model?
No. No, there is no as such. Basically, everyone do the same thing. Okay, there is one tool is there. I didn't remember the name of this tool. That tool is there. You put the data set over that tool, it will tell you that you can use this algorithm or you have to use this algorithm. But that tool is also not that much sure. Okay, to go to that precision or that accuracy level, you need to basically do the this kinds of thing. You need to try each and every algorithm. Fine.
Okay,
So
thanks.
this is something the drawback of the machine learning you can say. Okay, when you will read the deep learning thing. Okay. Okay, so moving to this thing, okay, let's quickly see the what are the challenges associated with the machine learning. The first one is the data collection. See, this is the very challenging part. If you are just learning the machine learning topics, so that will be not challenging. Why? You can get the data from some API. You can get the data by scrapping some website or some any kind of different sources. Okay, but when you are publishing some kind of research paper, so that's mean you need some novel kind of data. Okay, so what we were doing at IIT, we were just spending our 6 to 8 months in just collecting the data, and after 1 to 2 months in just implementing the algorithm. So you can assume that how much important is your data collection part. Okay, that takes a very long time. After that, the same thing, insufficient data. They're struggling in finding the accuracy of that particular data. Okay, and okay, and something, this is non-representative data. That means maybe your data is incomplete in nature. It may have some noise. It may be biased in nature. Okay, suppose if we talk about the biasness, so we can take one example. Okay, suppose you are collecting the data for winning probability of India. Okay, in cricket. So what happened when you will ask all the Indian, so what they will definitely say that the India will win. Yes. So this is something called the biasness in data. Okay. So to exactly find out which country is winning the data, you have to ask opponent country opponent country members also. Okay. So this is how you can basically overcome with this biasness. So this thing come very usually in data. The biasness happen in the data set. Okay, so this is something bias come in the sample data. After that, noise may also come. The noise means something irrelevant data that comes to your data set, and you need to define that data set. Okay.
Abhinay, bias will be in which format? 1, 0 or numerical or text format? Something.
No, bias.
Because in your first class,
No. That bias was something different.
acha,
This
that was different. Okay.
Yeah, that bias was basically a component of your weight and bias, your machine
Weight
learning.
and bias in under nodes,
Yeah,
right?
yeah. This bias is something your English you can say means giving the result in one favor. That is the biasness.
Okay.
Okay. So when you will ask to all the Indians, so they will certainly say that India will win. So this will basically bring the biasness in your machine learning model. Okay. Once you train over that particular data. So we have to basically take care of these things also. Okay. So there should be no biasness in the particular model. Fine. After that, the poor quality of data. Okay, we have to always remember that the data should be of the very good quality. How you can ensure that this thing should be there? There should be no missing value. There should be no outliers. Okay, and it should be in good format. That the data should be in a structured way. It should not in a raw way. Okay, so missing values clear, outliers. So I told you. Okay. See, yes, this anomaly, this is your outlier. All the data are coming in this range, but this certain amount of data, this particular data is coming in some different range. Okay, so this is your outlier. So we need to remove these kind of data. They may affect the result. Okay, and we can take the quick example. Suppose you want to basically find out the placement scenario of a particular college. Okay, so how you can do? Suppose all students are getting between 2 to 3 lakhs and one student get 32 LPS etc. Okay, so that will bring the outlier. This 32 is the outlier for placement data. Fine. And this not good in format mean your data should be structured. It should be always in the row and the column form. Okay, then only you can basically deal with the machine learning model. Okay, after that, irrelevant feature that I already told you in the last class, garbage in, garbage out. If you are giving some irrelevant data to your data set, so that will basically give you the irrelevant result. So this is something. Okay, after that, these are two important things: overfitting and underfitting. So we can basically understand this thing by a quick example. There is one exam, SSB. Maybe many of you have heard about this. SSB is the Service Selection Board. Okay, it is basically used to recruit the officer in Army, Navy, and Air Force. Okay, so what the candidate do? Candidate basically go for coaching, and on the day of doing some task in SSB, okay, they basically do the same thing. They basically replicate the coaching task. Okay, what this thing should not be done. This thing should not be done. This thing are not required at the time of the SSB. What the candidate are doing, they are basically performing in the same way what they have learned in their coaching. Okay, so the officer who are basically judging or what they are who are the seeing the thing. Okay, they basically see the candidate is performing in some you can say some overfitting manner. Okay, they are in the same manner just like they have been taught in the coaching. So this kind of scenario is known as overfitting. That's when your data is trained very very well upon your training data. Your model have been trained very very well upon your that you can say on your training data. Okay, when it comes to the new task, so that candidate will unable to perform the task when it comes to the new task. Why? Because it was used to perform the same kind of task that he learned in his coaching. Okay, so this is the scenario of your overfitting. When we'll talk about the underfitting, the same thing. Okay, it have the lack of knowledge. Suppose he does not went to any kind of coaching or something, so he will definitely have some kind of knowledge. So at that time also he will unable to perform the new task. Okay, so this is how you can basically differentiate between your underfitting and overfitting.
Is it like past
Fine.
data is similar to overfitting and new data is similar to lack of knowledge?
No, can you just pardon once again?
I was just thinking, is it like past data? Since we have past data, is it similar to overfitting and new data is
Mm-hmm.
similar to lack of knowledge? Since from
Uh,
the past data, yeah, means model can definitely knows what to do. But if we provide a new kind of data, it will not know kind of due to lack of knowledge something.
yeah. Both thing happen in see due to, you just mentioned this thing due to knowledge. Okay, this condition. So what happened when you train the model on your past data itself again and again. Okay, so it have not come to the new kind of scenario. So maybe you can say it is having the due to knowledge, it is not giving the good result. Okay, when you will talk about the underfitting, the same thing happen. It has not been trained on any kind of data, so though it will be the new kind of knowledge for him, right? So again it will not perform the good on that condition also. So what we need a good fit. Good fit is a condition where we don't see underfitting and we don't see overfitting scenarios. Fine.
Right.
Okay, so once you read this thing, that will make more sense. Overfitting occur when the machine learning model is too complex and learn those noise and irrelevant data, just like some make its coaching institute. Okay, in the training data instead of the general pattern. So what happen in the exam, suppose the new questions come, so it will not perform in that particular way. Okay, so when you will talk about the underfitting occur when the machine learning model is too simple to capture. It does not have any kind of prior knowledge also, so it will not capture any kind of underlying pattern present in the data, but then also it will fail. Both are the scenarios where your machine learning model fail if it is comes to the underfitting or it comes to the overfitting. Okay, so you will see in the machine learning these are some very very important two terms: your underfitting and overfitting. These things will come more often. Okay, so we need to process our data in such a way that we should always overcome these two categories: your underfitting and overfitting. Then only we can have a good kind of model. Fine. And this kind of fit is known as a good fit. So this is your third category, you can say. Okay. Again, the problem is software integration. Okay. Because what happened, you just made one machine learning model and you are using in your console. You have not integrated with any website, you have not integrated with any kind of Android app or something. Okay, so software integration is very very complex in machine learning models. Okay, because some libraries have not come in Java. Okay, only few people do practice the machine learning in Java, in JavaScript also. Okay, so that's why the software integration is quite complex in today's day also. After that, the cost involved. The cost is too much in training the machine learning model if you are using high-end data. Okay, if the quantity of the data is very large, right? So these were some, you can say, the challenges that you majorly face in the machine learning, and see, this will be not that much. Okay, you're overfitting and you're underfitting. So these are the two major challenges that you will definitely face while you are basically pre-processing your data set, right? So we have to keep in mind that it should not happen. Okay. Okay. Just we will finish this thing. Okay. Machine learning development cycle. So machine learning development cycle is nothing but your all steps involved from problem to solution. Okay. So machine learning or development cycle is basically consists of 9 to 10 steps. Okay. Moreover, it is having 9 to 10 steps. Okay. And it will basically start from your problem, what kind of problem you are solving. Okay. What are your reason of interest? In which sector you want to basically apply your machine learning algorithm? It may be your healthcare, it may be your sport, it may be your education, and so on, so on. Okay, so starting with this thing, we will first classify and we will understand what kind of problem that we are going to solve. Okay, after that, what we will do the data collection. This is very important. Okay, where we can get the data, we can get from the API, from scrapping the data set, different website, different resources, and so on and so on. Fine. And what after that, what we will do, we will do the data pre-processing and exploration. Okay, so what does this mean? The data pre-processing mean, what we will do, we will basically do the EDA is basically exploratory data analysis, that we are exploring the data in a univariate. That means you are basically exploring your one column of your data, two column of your data, or you can say the multiple means more than two column. That means you are just looking at the data of one column, two column, and three column. Okay, and you are pre-processing that thing. We will see how the pre-processing will work, so on and so on. Okay, so this is your third step. After that, what you do, you basically do the feature engineering. The feature, I told you that the feature represent your input, whatever the input column you have in your data set. Fine. Just like we have taking the example, this thing. Suppose you are having the room and the bathroom, I guess. Okay. Bathroom in the two column. Your room is there and your bathroom is there. So cumulative, what you can do, you can basically erase these two columns and you can just write one area. And area, suppose whatever the measurement you want to give, so you can use only one column instead of writing the two column. Okay, I told you this is something dimensional t reduction process. Okay, so this is how there are more number of process also there in the feature engineering. So this is your fourth step. Fine. After that, what you need to do, you need the model selection. So this is important. Which model you are using? You have to use the linear regression. You are using the decision tree. You are using some kind of neural network. It is your deep learning. Okay, or you are using some logistic regression, so on and so on. Fine. Compare the different model based upon the accuracy, speed, and the complexity. And whichever the model is giving the good result, just opt that particular model. Suppose logistic regression is giving good accuracy. Okay, so what we will do, we will choose the logistic regression. Okay, once we made the model using logistic regression, what we will do, we will do the model training and model tuning. Fine. So we will do the hyperparameter tuning, just like your number learning rate, just like your number of layer present in this, or you can say the epochs. how many times you want to train the model on the same kind of data. Okay, epochs is nothing but you do. We will see later on how this will work. Okay, after training the model, what you will do the evaluation of the model. And evaluation, I told you, just like in a cricket, what you evaluate each over by one parameter, and that parameter is run rate. In the same way, for the model, you use accuracy, precision, recall, and F1 score to basically evaluate your model. How much is the accuracy of that particular model? Fine. And we check for the overfitting and the underfitting also. Fine. After that, once the model is trained, once the model is ready, so what we can do, we can deploy the model in our production server. Okay.
We have not included bias in this one, model evaluation.
No, you can include. There's nothing but you can include this thing in the model evaluation. It will not work. It will work on this data preprocessing.
Okay.
Yeah, it will work over here because right now we are dealing with the data only. Once the data is trained or it is ready, okay. After that, we will do the model selection and all those things. Okay, we will do over here. Fine. Model evaluation is there, model deployment is there, and after that, once the model is deployed, okay, what you need? You need the maintenance. So you need to keep the maintenance of the particular model. Okay, so it will be basically used by the end user or some stakeholder or whoever for whom you have made the particular model. Okay, so this is something your machine learning development life cycle. This is how from the scrap, from the problem to the end user, you are making the machine learning model. Just like a software also, in software engineering we study one topic, software development life cycle. So from here the machine learning development life cycle has came. Okay, so the feedback, you can say, see this last one, iterate through the ML SDLC based upon the new requirement or changing the data. Maybe we want online learning over here. Okay, maybe it is a recommendation type of model. So what we need the feedback loop, right? We need to basically again change the data. So just not only by deploying into the production would not make the entire machine learning development life cycle. After that, we also need to take care of that particular model that, okay, it will work for the new data also. Okay, with the help of the online learning. Making sense?
What is the
Anyone?
difference between model evaluation and feedback loop? Once we have evaluated the model and observed that it is working fine, it's okay. Then once we get a feedback that the model which you have developed or designed is not working properly, then somewhere down the line we have not done our job perfectly under model evaluation, right?
See, model evaluation is basically, you can say, unit testing.
Unit testing, okay.
Okay, it is done by the developer only, moreover. But feedback loop is basically done by the end user. This is the small example. Suppose you basically you are making a recommendation system, and again you are giving a kind of data, the new data. Fine. So what you will do? You will again train the model. So after that, what you need? So this is the kind of getting the feedback or basically keeping the eye on that particular model or the particular data set present in the server, right? So this is the need of feedback loop. That model evaluation was done by unit testing, okay, and this was mainly done by the you can say the developer itself, okay.
Okay, got it.
Okay, basically, see, the thing is that now it is basically done in the local environment. Once the model is deployed, so local environment and your production environment both are having very changes. The environment completely change. Fine. So it may not work over here. So we need the feedback kind of loop. So we basically get to know whether the model is working on the production server or not, right?
Yeah, that's true.
Okay. Okay, so in the next class, what we will do, we will basically go with more depth. Okay, we will study about tensor and all those things. Fine. So I guess any doubt to anyone till here, from the online learning, instance-based learning, model-based learning to machine learning development life cycle. Anyone?
One more thing, exactly where we store this data set in a database, or which kind of database is usually preferred for storing such kind of huge data?
See, right now for storing the data, we use only CSV file only.
Okay,
Okay, and that CSV file is basically stored in your, if you are using this system, so you are using your hard drive or this SSD. Okay, when you will talk about your environment or the production environment, so in that there is one thing, bucket is there. S3 bucket, it will talk about the AWS.
right.
Okay,
That's right.
so we can use that also for storing the data.
Okay. But fetching means continuously fetching data from a file. Will it not take much time? It should take more
That
time since your data means file will grow very large in, let us say, GBs, and also
okay.
sorting, filtering, how it is done.
No, see, those steps are done priorly, okay, before moving the data to the production. That things are done before that thing, before the deployment in the server only. Your evaluation, okay, your pre-processing, everything has been done in your local system only before moving to the production server. Okay, once your model get trained and it is good to go to the production server, then only you basically push the model in your production server. And after that, if you want to retrain on some particular amount of data, that will come to the your online learning. That will not take that much of time because that data will be small in nature. Yes. If it is
But
large
slowly
in
the
nature,
data will grow, right? If you have
so
old data means daily, just like let us say, for example, Chat GPT, there are means the kind of data which they are storing.
okay,
Yeah, I
okay.
was just wondering means exactly where that data is getting stored. Are they using any RDBMS kind of thing or file system or
For that, I don't think maybe they were using a kind of RDMS. For the OpenAI, I think they don't use any kind of production server. They have their own machinery at their workspace. They have their own TPUs also there, along with that data storage is also there. So just like what we did, it is a much more different thing. This is something different concept because they can't use na AWS for training that large amount of data. So
right?
very normal that they may have this
They
is
have GCP, right?
sorry.
No, no, Gemini has GCP. Okay, yeah, right.
Okay, Gemini is basically a Google Cloud platform.
Google
GCP.
Cloud. So Google Cloud, yeah, right.
Yeah. So they may basically utilizing these as a your local system only. Now, if we train our model in our local system, what do we do? We basically have our own GPU. Suppose this is our GPU and this is our storage, your HDD, and we are using the combination of both to basically train the model. Making sense?
Yeah, right.
Yes. So in the same way, OpenAI is also working because they have the large facilities and they have a lot of money also. So they have made their own environment in their office or lab or something. Okay. So they were not using cloud for this thing. That I can assure you. Because the cloud is something where you basically train a little amount of data, not that much amount of data because I don't think any cloud is having that much of capacity that you can train the 70 billion parameters, okay, or 70 million parameter or 7 million parameter in a cloud itself. That will certainly take a lot of time and even resources also.
Yeah, right.
Yes. So, okay, fine. So we conclude with this, okay, and We'll connect tomorrow. Okay, fine. Thank you for joining us. Thank you. Thank you.